Hey everyone, today I'll be doing the week 2 AMS quiz of math. So first we're going to start off with question 1, which is the different ways of combining. Our object from a set of n objects is denoted by NCR. This we call it NCR. Okay, which of the following is true? Select all that apply. Now, for this one, I have a very easy trick for you. There's two different ways. You can either, let's take the first example, just so I can show you how to do it. Equals 262. Okay, you can either check if these two bottom ones, okay, add up to the number on top. So in this case, it's 6. Then yes, it is correct. Now, there's also the other way, which is if, for example, 64, I'll write it again, because 262. If you subtract this number from the top number from the bottom number, and you get 2, for example, here, and you can find it in the other one, you will, as you can see here, it's also 2 in the other one, then it's true. So let's check for the second case now that we've proved that it's true for the first, using the two methods I just explained. So this is true as we know. Now, 10C4 equals to 10C6. Okay, so add these two numbers up first. 10. Yes, so as far as I'm concerned, this is correct. However, say you don't like this method, you want to check for using the other method. Subtract 10 from 4, 6. 6, as you can see, is here, which is true. Subtract 10 from 6, 4. 4 is here, so it is true. You can also, of course, always do it on a calculator. Now, how do you do this on a calculator? So, first, you write the number at the top. In the first case, it's 6, right? I'm taking this case here, the first one. 6. Then you press shift and then the division on your calculator, and then you press 4. You check what value it is. In this case, 64 is equal to 15. Now, let's check for 62. So just swap the 4 out with the 2. 62 is also equal to 15. This is the proper notation, by the way. Ignore this. This is because the numbers are too big. This is true, and you can always do this on a calculator. Anyway, even for the second case that is in this question. Question 2. What whole number is equal to 18 factorial over 4 factorial times 15 factorial? Now, first off, I want to start with explaining what a factorial is. Suppose you have an integer n, any number n. N factorial is going to be equal to n into n minus 1 into n minus 2 into n minus 3, all the way until you get multiplied by 1. So let's take an example. Let's take 5. 5 factorial. 5 factorial is going to be 5 times 5 minus 1 is 4 times 5 minus 2 is 3 times 2 times 1. And that's the 5 factorial, which is equal to 120. Let's also take 4 factorial as a simpler case. 4 factorial is equal to 4 times 3 times 2 times 1. 4 times 3 is 12 times 2 is 24. Okay. Now that we know what a factorial is, there's also a different way of writing out what a factorial is. For example, let's go back to n factorial, okay? You can write n factorial as n times n minus 1 factorial, or n minus 1 or n into n minus 1 into n minus 2 factorial. So you can also write it like this, into n minus 2 factorial, so on and so forth. Obviously, this can just keep on going. You can even write n into n minus 1 into n minus 2 into n minus 3 factorial, whatever, you know what I mean. Okay, so we're gonna do this. We're gonna solve it like this. First of all, for questions like this, you can always do it on a calculator. So I'm gonna start off with the calculator method. To get a fraction, press 18. Obviously, you know how to type in 18. Shift, and then on the top row of your calculator, I think, if you're using the one that I'm using, which is the one that most of you have, the green or black one, the one that has x to the power of -1, press shift on it. Shift, then press it. 18 factorial. Now, you do the same for 4 times, do not forget the times symbol, because if you write it without the multiplication symbol, you will get syntax error. Times 15 factorial, the answer is 204. However, what if they ask you for it in a written part? A written part question, you're gonna have to show your work. So, we're gonna use this definition. N factorial is equal to n into n minus 1 factorial, and obviously this can keep going for n minus 2 factorial, n minus 3 factorial, whatever. Start at the bigger number. Compare all the numbers here. What are the two biggest numbers? 18 and 15, right? 18 is bigger than 15, so we're going to expand 18. So 18 factorial is equal to 18 times 17 times 16 times 15. Now, once we reach the second biggest number, you're going to want to write the factorial symbol. right? For the second biggest number at this position. So this is equal to 18 factorial. Now, we're just going to write it down in the fraction. So it's going to be 18 times 17 times 16 times 15 factorial over 4 factorial, 15 factorial. Now, why did I do this? Because now I can very easily cancel 15 factorial from both sides. So what I'm left with is 18 times 17 times 16 over 4 factorial. Since we're assuming this is written quite, you're going to have to expand on 4 factorial, show what that is. 4 factorial is equal to 4 times 3 times 2 times 1, which equals to 24. So now that we know this, we can just write 18 times 17 times 16 over 24, which equals on a calculator 204. Done. Problem solved. Okay, moving on. Fill in the blanks with numbers only. Written in terms of factors, n plus 2c3 is equal to all of this, where a is equal to this and b is equal to that. Now, there is a formula for finding combinations. For finding combinations where it's written as like this, which is the same as being it's written like this. This is the same thing. These two mean the same thing. The formula is n factorial over r factorial or into n minus r factorial. This is our formula. This is what we're going to apply. So I'm going to leave it up here. So nr is equal to ncr, which is equal to n factorial over r factorial n minus r factorial. Now that we have this up here, we can use this for our working. Now, n plus 2 c3. Sorry, let me just erase this. This is equal to, this is an n plus 2. n plus 2 factorial over 3 factorial into n plus 2 minus 3 factorial. We're just applying the formula. Now, n plus 2 factorial, we have nothing to do with it yet. We're going to simplify this later on. But for now, we're just going to expand our terms and see what we have. n plus 2 factorial, 3 factorial. n plus 2 minus 3, 2 minus 3 is negative 1, so n minus 1 factorial. Now, we're going to look at the biggest number. Okay, so here, in this case, we're going to be working with n, right? Obviously, we want to be working with the n, so we can cancel something out at least, make our lives easier on us. So, which is bigger, n plus 2 or n minus 1? n plus 2, right? So we're going to expand n plus 2 and stop once we reach n minus 1 factorial. So, let me erase everything. So, n plus 2 factorial over 3 factorial n minus 1 factorial, just so I know where I am at. Now, n plus 2 factorial is equal to n plus 2. Then we're just going to keep subtracting 1. Sorry, n plus 2, n plus 1, n, and then n minus 1. And then since we reached n minus 1, so we have n minus 1 at the top and bottom, I'm going to add the factorial symbol here. So, I'm going to write this down now. n plus 2, n plus 1, n minus 1 factorial over 3 factorial, n minus 1 factorial. I'm going to cancel my n minus 1 factorial out. So I'm left with n into n plus 2 into n plus 1. I'm writing it in the form that they want me to write it as here. Over 3 factorial. Now I just have to expand what 3 factorial is, and I get my answer. 3 factorial is 3 times 2 times 1, which is 6. So my answer is n into n plus 2, or sorry, n plus a, and we have n plus 2 given. So I'm going to write n plus 1 here just to match it, and n plus 2 over 6. Now, they want me to find a and b. n plus 2 is given, so I'm just going to cross it out on both sides. N is given, so I'm going to cross n out. It leaves me with n plus a over b is equal to n plus 1 over 6. Right? So as I can tell from this, a is going to equal to 1 and b is going to equal to 6. And this is how I solve my problem here. Moving on. Question 4. This one is going to need a little bit of focus. Now, first off, I'm not going to concern myself with these for now. What I'm going to concern myself with is this summation here. So basically, for a summation, k equals to 120, 2k squared minus 3k plus 2. Okay, first of all, I can distribute, these are some rules you need to know for finite sums. I can distribute the summation to all of them. Okay, so this is going to actually equal to the sum of 2k squared, from k equals to 1 till 20 minus the sum of 3k from k equals to 1 to 20 plus the sum of 2 from k equals 1 till 20. Now, this is the first rule. The second rule is when I have a summation. Okay, I'm going to erase this first part now because I don't need it anymore. When I have a summation, any constant, I can take it out like this. I can take the 2 out and the 3 out. Obviously, given that I have a variable next to it. Yani this 2, I can't take it out and have 2 multiplied by the sum of... Actually, you can. You can do that. But I wouldn't recommend it. Yani you can take this constant out and have 2 multiplied by the sum of 1 from 1 till 20, but that's useless. Why would you need to do that? So only take them out when you have variables for your own convenience. So this is actually going to equal 2. Now we're going to move to this. So it's going to be 2 multiplied by the sum. Sorry, let me write the sum properly. The sum of k equals 1 till 20 of k squared minus this 3 multiplied by the sum of k from k equals 1 till 20 plus the sum of 2 from k equals 1 till 20. Okay, now that I have this, again, I'm just rewriting it in ways that make it easier on me. This is where these 2 parts come in. Okay, when I have these, what can I do here? Very easy, very simple. I'm going to substitute the formula into the summation. So it's given to me that why can't I? There we go. It's given to me that the sum of k squared from 1 till n is this number here. Now, in this case, since you can see that the sum of k squared is from 1 till 20, 20 is our n here, right? So I'm going to write this down. I'm going to substitute k squared for this formula. So 2 into 20 plus 1 over 2, right? Again, it's given to me. I'm going to explain this again. It's given to me that the sum of, oh, sorry, this is the wrong formula. Wait, my bad. The sum of k squared, here, this is the formula I need for this part. The sum of k squared is n into n plus 1 into 2n plus 1 over 6 from 1 till n. In this case, I have the sum of k squared from 1 till 20. So obviously, 20 will be my n. Meaning that I can substitute this formula for the sum of k squared. Since it's given here to me k squared and the sum of k squared in both cases. So I can obviously substitute. This is principles of math. So instead of the n here, I'm going to substitute 20 for it. So 20 into 20 plus 1 into 2 times 20 plus 1 all over 6. Right? Now the space is too small for me here, so I'm gonna need to do this very quickly. 3, and again, it's given to me that the sum of k is n into n plus 1 over 2, where k is, the sum of k is from 1 till n. N again is 20 here, it's given to me. So I'm gonna substitute the formula for this sum of k. So it's gonna be 3 times n, which is 20, into 20 plus 1 for my convenience. I'm just gonna write it as 21 right away, over 2. Now, I don't have much space, so I'm gonna do this last part mentally. This now, the sum of any constant k, where k starts from 1 till n. Okay, just memorize it. There is an explanation behind it, and I can explain it, but it's unnecessary. It's simply gonna be n times k. That's it. Very easily. Let me write it with different colors because it's blending in. It's gonna equal n times k, nk. Okay, that's all you need to know. Where it's obviously given that k is starting from 1. So in this case, we have the sum of 2 from 1 till 20. So applying this formula, sum of 2 from k equals 1 till 20, it's going to be 20 times 2, which is 40. 40, I can't write the 0 here. 40. Okay, so we're gonna add 40 to this, right? Since I don't have space, I'll add it at the start. Obviously, it doesn't, actually, we'll add it later once we evaluate all of this. What did I open? 1 second. Oh, okay, it's all gone. So I can rewrite it now, very easy. So it's gonna be 2 into, what was it? 20, 21, then 2n plus 1, 41 over 6 plus, again, I'm just, because the writing, my working went away, so I'm just rewriting it. But instead of writing n into n plus 1 to n plus 1, so substituting n for 20, I'm just substituting and multiplying directly to save space. So minus, sorry, this is going to be a minus 3 into 20 into 20 plus 1, which is 21 over 2 plus we said it was 20 times 2, which is 40. So now this can be very easily done on a calculator. So 2 into 20 into 21 into 41 over 6 minus 3 into 20 into 21 over 2 plus 40. 5,150 is my answer. Okay, moving on. Write the coefficient of the x cubed term in the expansion of 4x minus half to the power of 8. Okay, for this one, you're gonna need to know the binomial theorem, the binomial expansion. So, for binomials, you can expand them using this theorem. So, 4x minus 1 over 2. Let's take this as an example. Or actually, let me give you the general form. Let's say you had ax plus b. Okay, to the power of n. Once you have this, obviously you can also have x here, but that's another story and not needed right now. Once you have this, ax plus b. So, the formula is the sum. Always, by the way, when you're solving, I prefer that you write in sigma notation the general expansion, then you actually begin solving, which is what I'm going to be doing here. Sum from k equals to 0 till n. N is our power of nck, okay, into the first term, ax, to the power of n minus k, and then this is going to be multiplied by b, which is going to be to the power of k. Okay, and this changes every time, obviously, because k will increase by 1, and then 2, then, yeah. So this is our general form. Now, I'm going to apply it here. So, 4x minus 1 over 2 to the power of 8. Well, you have this. Okay, what do I do now? I'm going to apply the general form. First, I'm going to write it in sigma notation. So, k equals to 0 till n is equal to 8 in this case. 8k into 4x to the power of 8 minus k multiplied by negative 1 over 2 to the power of k. Right? This is just the general form. Okay? Over time, you learn to familiarize yourself with it. You can write it either very quickly or you won't even need to write it at all. So, now, x cubed term. Okay? For the x cubed term, and now what I prefer, always, checking this condition here, 8 minus k, where you see an x, it has to have a cube or a 3. So what do I mean? Basically, here in this case, 4x to the power of 8 minus k. 8 minus k has to equal 3, because remember, you're going to distribute this power, right? You're going to distribute this onto this, so onto the 4x, right? So once you multiply it, you'll have 4x is going to be equal, raised to the power of 8 minus k, right? So 8 minus k, you want it to equal 3, because you want x to have the third power. So take this to the other side, k is going to equal to 5. Okay, so we're going to now expand it. I erased it by accident. So we're going to have 8, 5. Now you don't need to write the sigma notation. 8 and 5, 4x to the power of 8 minus 5 times 1 over 2 to the power, sorry, negative 1 over 2 to the power of 5. Okay, here's my calculator. So remember, this is equal to 8c5. So you're going to do that on the calculator. 8c5 times 4x, or sorry, the x, obviously you can't write it on the calculator like this, so we're just gonna write 4 cubed because they want the coefficient. So we're gonna ignore the x as if pretend it's not there. 4 cubed multiplied by negative 1 over 2 to the power of 5. It's gonna give me negative 1, 1, 2. Okay, then obviously I add the x cubed because I distributed onto both the 4 and the x. However, they only want the coefficient, so we don't include this as part of our answer. You do this only, negative 112. Okay, question 6. Written in terms of factors, m plus 1 c3 is equal to, this is the same concept as the question I did like 3 questions ago, and it's better practice. In fact, this one's actually going to be very, very good practice. So, m plus 1, 3 is equal to m plus 1 factorial over 3 factorial m plus 1 minus 3 factorial. Now, n plus 1 factorial stays the same, into 3 factorial. So, n plus 1 minus 3. 1 minus 3 is very easily negative 2. So, n minus 2 factorial. Now, which is bigger, n plus 1 or n minus 2? N plus 1. So, we're going to expand n plus 1 factorial. So, this is actually going to equal to, I'm going to write it all the way down here. N plus 1 into n minus 1 into n minus 2 factorial. I reached n minus 2, I write the factorial symbol. Okay, again, I'm just expanding this. So, 3 factorial over n minus 2 factorial. Cancel the factorials out. You'll get this equal to n into n plus 1, n minus 1 over 3 factorial. You should know by now it's 6. So, I have this form, very similar, right? So, I have it given to me that n is given, n plus 1 is given. So, I'm going to cross n and n plus 1, leaving n minus a and b. Obviously, I can see here that minus 1 is going to be a, it's n minus a. So, n minus a is equal to n minus 1. Right, n minus a is equal to n minus 1, right? So, cancel the n from both sides. Negative a is equal to negative 1, a is equal to 1, right? Obviously, I'm explaining, this is meant to be done mentally. I shouldn't really have to explain because it's in the same form. But for the people that don't know. And b is 6, obviously, this is, I don't need to explain it. Now, n plus 3 and n minus 1. So, n plus 3, c n minus 1. This is going to equal to n plus 3 factorial into n minus 1 factorial into n plus 3 minus not only n minus 1, no. You're going to write n minus 1 in brackets factorial because it's the entire term. This is your r. All of this is your r, right? So, we're going to distribute and expand. So, first of all, n plus 3 factorial stays the same. N minus 1 factorial stays the same. Now, distribute the negative sign, right? You're going to have n plus 3 minus n plus 1 all under a factorial symbol. Let's simplify this. So, n minus n will cancel. 3 plus 1, 4. So, multiply this by 4 factorial. Don't forget the factorial. Now, I'm going to remove this so I can have more space to work. Which is bigger? Sorry. N plus 3 or n minus 1? N plus 3. So, we're going to expand it and stop when we reach n minus 1. N plus 3 into n plus 2 into n, or n plus 1, sorry, into n minus 1 factorial. Let me erase this part now. All over n minus 1 factorial multiplied by 4 factorial, if you remember. So, n minus 1 factorial will cancel with n minus 1 factorial, leaving me with n plus 3, n plus 2, n plus 1 into n over 4 factorial. 4 factorial is 24, so that's n into n plus 3, blah, 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 whatever, n plus 2, and then n plus 1, whatever. Okay. Actually, I'm just going to work with it like this. I'm going to erase this 4 and make it 24. So now that we erased this part, خلاص, we cross them out. 4 factorial is equal to 24, and this is our final answer. Now, we have n given, so we're going to cross out n. We have n plus 1 given, so we're going to cross out n plus 1. We have n plus 3 given, n plus a is going to be 2, b is going to be 24. Done. Okay, question 7. The third term in ascending powers of x of the expansion of 1 plus 4 x to the power of 5 is whatever. Okay, now, the third term, listen. K, if you remember from the summation, K starts from 0, not from 1, K till N. It's going to be N, K. This is another chance for you to memorize the general form of the, because I'm rewriting it, the binomial expansion. So it's going to be ax to the power of N minus K into B to the power of K. K starts from 0, not from 1, from 0. So count on your fingers. 0 is the first term. K equals to 0 is the first term. K equals 1 is the second term. K equals 2 is the third term. So we're going to write 1 plus 4x to the power of 5. First of all, again, always write the summation, the sigma notation first for this expansion. K is equal to 0 up until 5. 5 ck 1 into, what was it? 5 minus k into 4x to the power of k. Okay, this is our general form for this summation. Now remember, k here is equal to 2, so it's going to be 5c2 into 1, 5 minus 2, and 4x to the power of 2. Do this on a calculator now. 5c2 multiplied by 1 cubed is always going to stay 1 into 4 squared, 16, x squared, obviously 160, and then distribute the x on the square, x squared. So 160 x squared is my answer. Remember, basically, if they want the nth term, okay, the nth term of the expansion, just remember it's always going to be k is going to equal to n minus 1. So in this case, third term, k was equal to 3 minus 1, which makes k equals to 2. Done. Okay, that's all you need to know from this question. Question 8. What's the value of 0 factorial plus 6 factorial? Where did my entire thing go? 0 factorial, always remember this by the way, 0 factorial is equal to 1. Okay, 6 factorial, you can do it on a calculator. 6 factorial, I believe was 720. Let me just make sure. 6 factorial 720. Yeah, okay, so this is actually just 1 plus 720, which equals to 721. Done. Question 9. If 120 times 119 times 118 times 117, okay, this is another thing about the n factorial is equal to n into n minus 1 factorial. It's just an application. Okay, so here 120 times 119 times 118 times 117. This is obviously signaling that we're starting with 120 factorial, right? We're starting off with 120 factorial. But if you noticed, where did the rest of the numbers go? Because remember, we're supposed to start off with 116, then 115, then 114, all the way until 1. Yeah. Now, again, this is another way of rewriting it. So you can rewrite 120 factorial as 120 times 119 times 118 times 117 times 116 factorial. Remember, this is an application of the n factorial equals n into n minus 1 factorial. Right? You can always do this. Okay. Now, you have this. We're getting very close to what our original thing is, as you can see here. But now you might be asking, where did the 116 factorial go? That's where this comes in. You can write 116 factorial plus just 116 factorial. So when you divide these two, 120 factorial, when you divide 120 times 119 times 118 times 117 times 116 factorial, actually, let me just rewrite it here so I have more space. 19 times 118 times 117 times 116 factorial, and I divide by 116 factorial, you can see these two cross out. I'll be left with exactly what I have in the question. So this is basically the answer, 120 factorial over 116 factorial. Done. This is my answer. Question 10. Again, always do this on a calculator, or I'm teaching you how to do it by hand, just in case any of this comes in a written part. 21 factorial is equal to 21 times 20 times 19 factorial. You should know how to do this mentally by now. Basically the same thing as the other question. 19 factorial, cancel. 21 times 20, obviously, is gonna be 420. So let me just make sure I calculate. It's 420. This is my answer. Done. You can see over time you do pick this up. Oh, this is a perfect example of the thing that I said in the first question about the combinations. Remember, first of all, these two have to add up to 125. Okay, these two always have to add up to 125. And if you subtract 125 minus n, you're gonna have to get 5. So you can do it both ways. I'll explain to you both ways. N plus 5 is equal to 125. Take this to the other side, n is equal to 120. Now you can also do it the other way. This is basically, by the way, those two ways I taught you is there's just one equation, but you're rearranging it both times. Okay, this was the first way. Now the second way, where you subtract 125 minus 5 and you get n. So 125 minus 5 will equal to n, and n is equal to 120. Done. Moving on. What is the value of 10C6? You do this one literally on a calculator, makes your life very easy. But again, you can recall the formula, NCR is equal to this bracket column notation thing, which is n factorial over r factorial into n minus r factorial. Now, Doing this by hand is going to give you 10 factorial over 6 factorial. 10 minus 6, I'm going to do it in one step. I'm not going to write it down. 4 factorial. So do this on a calculator. 10 factorial over 6 factorial times 4 factorial. Now, 210. But of course, yani you can always do this very easily on a calculator. Just write 10C6. Literally, write 10C6 on your calculator. Again, the C button, the NCR button is shift divide. So 10 shift divide 6. 210. It's way faster, but I'm teaching you how to do it by hand, just so you can know. Now, this is very easy. So it's the rule where you can take the constant out of the summation when you have the variable along with it. So it's given to me that 100 of the sum of 1 to 100 for Ci is equal to 20, right? Now they want the sum of 10 Ci from I equals 1 till 100. I take the 10 out, it's a constant, so it's going to equal to 10 sum Ci I equals 1 till 100. Or sorry, yeah. Now, this basically, it's given to me. The sum over here, literally the second word in. If the sum of Ci from 1 to 100 is 20. So instead of writing it all like this and leaving it out, I can erase this and just write 20 here. Because they're the exact same thing, right? I'm substituting. So 20 times 10, 200. And that's my answer. Moving on. Out of curiosity, how many questions were there left? 16 or almost there? Okay, question 14 I think. Yes. What's the value? Was I in question 14? Yes, I was. Okay, question 14. What's the value of the sum of 2 from I equals 1 to 100? Remember, this is a rule I explained. If you have a sum of a constant, k, or n, sorry, where k is starting from 1 all the way till n, or we'll use a different, we'll use a. Here, you're gonna have, or sorry, wait, yes, this is fine. You're gonna have a times n, right? And the other one, I used n times k, they're the same thing. Again, they're just all variables in the end. So again, sum of constant, okay? And if you have any variable, if you have the summation starting from 1, sorry, moving all the way to a certain number, n, you're gonna have to multiply n by the constant. So applying it here, right? Sum of 2 from I equals 1, sorry, ignore this, to 100, it's gonna equal to 100 times 2, which is 200. Done. Moving on. Question 15. What is the value of sum of I equals to 1 for I 2I plus 1? Now, this very easily you do it on a calculator. You did summations last year in Algebra 4. And also my calculator, the one that I have on me right now, doesn't have the summation button, but most calculators do. So I can't do it with you on a calculator. Anyway, so we want to find this. Let's do it by hand, because obviously in the written part you're gonna have to do it by hand anyway. The calculator won't give you any marks on the written part. So we're gonna start substituting the first value of I that's given in the lower bound of our summation, and then just always increase I by 1. So in this case, it's gonna be 1 into 2 times 1 plus 1, okay, plus 2 into 2 times 2 plus 1 plus 3 into 2 times 3 plus 1, and then plus 4 into 2i, or sorry, 2 times 4 plus 1. Done. This is what our summation is going to equal to. So 1 into 2 times 1 plus 1, plus 2 into 2 times 2 plus 2, or plus 1, sorry, plus 3 into 2 times 3 plus 1, plus 4 into 2 times 4, which is 8, plus 1, 9, 70. So my answer here is 70. Okay. Question 16, which was our last question. Obviously, again, you can do question 15 on a calculator like this straight away. This is the rule where you can distribute the summation across all of them. So let's apply that. So this whole thing, I'm not going to rewrite it. I'm just going to set it equal to the sum of 50, the sum of pk from 50, k equals to 1, plus the sum of qk, where k equals to 1, into 50, minus, sorry, r as a sum of rk from k equals to 1 all the way till 50. Now, if you notice, all of them are given to me here, right? So I'm just going to substitute. So for example, this sum here, pk, it's equal to 25, right? So instead of all of this, I'm going to substitute 25. Instead of all of this here, I'm going to substitute 30. Instead of all of this, I'm going to substitute 10. So very simple and very easy. So it's going to be 25 plus 30 minus 10, which is going to equal to 30 plus 25, 55, 55 minus 10 is 45, and 45 is my final answer. Okay, done. This was the end of the quiz. Also, this was the end of the first math video for grade 11. Good luck, guys, for the whole year. Inshallah, you all do well in your academics this year. Inshallah, you do well on this exam, of course. Good luck. Goodbye.